Welcome back. In this video, I'm continuing the Leetcode problem, and for today, that's 1568 minimum number of days to disconnect island. It's a Leetcode hard. Okay, we are given mn binary grid where 1 represents land and 0 represents water. An island is a maximal 4 directionally horizontal or vertical connected group of ones. The grid is said to be connected if we have exactly one island, otherwise it's said disconnected. In one day we are allowed to change any single land cell into a water cell. Return the minimum number of days to disconnect the grid. Okay, so we can see from examples, if we have one island, it's connected. And we need to make it disconnected. That means we need to remove some soil to get more than one island, or to remove all islands. So generally, approach is to check if how many islands we have. If we don't have one island, then we return 0 because we don't need to change anything. It's already disconnected. If we have one island, then like in this example, we need to in both examples we need to remove 2, but in this example we removed all soil, and in this example we made 2 islands out of 1. So for me this problem was pretty hard because I didn't have the intuition that if we have one island, it is always maximally two two positions we need to like remove to get two islands out of 1. And that's what I got from hints. So let's check hints. Return 0 if grid is already disconnected. That's, yeah. 1 if changing a single line to water disconnect the island. That's okay. We just, if we have one island, we visit all. We try to remove each position of soil and then check if we have multiple islands. And this otherwise returned true. This part is what gave it, and especially this part. So if we can disconnect the grid within at most 2 days. And why is it so? Because whatever configuration we have, and we have one island, it's always enough to find the one like corner and just remove those 2. Like an example, if everything was an island, it would be enough just to remove these 2. If we had all these an island, remove these 2, and so on. So generally the approach is to check if how many islands we have. If it's not 1, then we return 0 because it's already disconnected. If we have 1, then we need to check if removing one position of the island will change the number of islands, and we can do that for each position of the island. And if that's not, if we haven't managed to have multiple islands or lose all islands, then we or if we still have one island, then we return 2 because 2 is enough. Okay, I hope it makes sense. So let's code it up. First I'm going to find the number of rows and columns. So grid 0. Okay, I'm going to have directions. So increase row, decrease row, increase column, decrease column. And what do we do? So first we need to find out the number of islands. So let me define number of islands. return, let's say it's 1 here, but so we need to see how many islands we have. So count is equal to number of islands. And if count is not equal 1 here, we return 0 because we already have disconnected grid. Okay, let's implement the number of islands. So first we need is to check. So first we need to find the starting of an island, or a grid position that has soil. So how are we gonna do it? We also need so visited soil to be equal to set to track to correctly track the number of islands. Okay. And what do we do? So for row in range of rows, for column in range column. So we need to check if so grid position RC is equal to 1. So we find not geared but grid. If it's 1, so we found soil, but we also need to check if it's not in visited. So RC, or maybe we don't need to, we'll see. And RC not in visited. So if this is true, we need to mark whole island. Also, we need count here. So count is equal to 0. Return count here. So if this is true, we found an island. So we increase our count. We add to visited row and column. And so we need to do the search within the neighbors for the to mark the island. So we need to track. So we need Q. Track what we need to visit. So Q DQ and Q dot add RC. Okay. So we now have we added with Q. We added so this position to the visited. We put it on the queue, and now while we have something on the queue, we need to mark all the neighboring grid positions that are equal to 1 as visited. So while Q, we're gonna get let's say XY. Let me just turn off my sound. This is like 3 times in a row. Okay, XY is equal to Q dot top left. Okay, so we get position, and so we need to check the neighbors. So for the in directions, TX dy is equal to t, and x is x plus dx, and y is equal to y is dy. And so if an x was the row plus the column, and so nx and y is not already visited, not in visited, and it's 1. So grid of nx is equal to 1. Okay, we need to add it to the queue. Append queue is append visit to this add. So queue append and x and y and visited and add and x and y. Okay, so let me just check it. So if we found grid of some position is 1, and if it's not visited, we count, we add it to visited, we push it to the queue, and while we have something on the queue, we mark all neighboring positions as visited. Okay. Okay, that seems good. And okay, I think this is okay. So here we get the number of islands, and if it's 1, if it's not 1, we it's a bit clear. So if it's not equal to 1, we return 0 because it's already disconnected. And so now we are sure it's 1. Now we need to change each position. We need to make, like, for each position of that island, we need to try to make it so we turn into the water and check if the number of islands has changed. To do it, we need to know where our island soil is. So we can just, like, modify a bit number of islands to get visited soil, because visited soil here will be only that island. So visited soil, we'll have soil like this. And if soil flag, we return count and visited soil. Soil flag is equal to true. Island soil. So now you're gonna get also the set that contains soil of an island. And what do we need to do? So for position in island soil, so we need to try to I need to remove it. So row column is equal to position and grid of position of row column is equal to 0. And we also need to, so we need to now count, let's call it new count is equal to number of islands. Soil flag will be false now because we don't need soil. So new count, and if new count is not equal 1, so we managed to either remove the whole island or make more than one island out of one, we return 1. If not, we make our grid back the same. So our C is equal to 1. And if this is not true, so okay, I think we return true to here. Okay. I think this is it. Let's try to run it. Lim visited soil. Okay. Visited soil. Let's run again. Visited. Should be. Okay, let's see our mistakes. Soil flag. Why it's not defined? Soil flag. Is it out of the... No? So, a lot of silly mistakes. Okay, it's accepted. Let's try to submit it. And yeah, so it's pretty efficient, both memory-wise and time-wise. Let's see if we can analyze. Okay, R times C. And it's also the same, I think, or in the worst case also should be R times C. Yeah. So why? Because for so when we are counting the number of islands, we need to check it for the all positions. So that's R times C, and we just check neighbors here. But if we visit neighbors, we won't do it again. So it's yeah, R times C should be R times C. Okay. And for the number of islands, for the space complexity, just let me check it a bit. So is said, yeah, okay, because of the soil. So yeah, this guy. Okay, I think I'm correct for that. If I'm not, please write it in the comments. Thank you for following this one, and see you in the next one.